apologetics. And I never have done one, and I'm on the age of the Earth, you know, in terms of radiometric dating and dating of rocks. But this little issue of starlight and time kept coming up. And I had some various answers, but I had never done an in-depth study. And an elder in my former church, his son left the faith after being raised in the church, casualty. I met with them first, and they were going to arrange a meeting with their son, and he was going to agree to meet with me, so that was great. I was asking them, because I didn't want to tread on their beliefs, what they believed about evolution, and they, you know, I think they kind of believed in it. I mean, their understanding of what evolution was kind of pretty much what the world is saying it was. So I kind of knew I wasn't going to be stepping on their toes, so to speak. But when I met with him, his issue was cosmology. And so he had a very shallow, he rushed into this decision very quickly. I think there was disappointment in his life, and this was a kind of a quick exit out because his life did not turn out the way it was. But it started me on this cosmology issue. So I have it on my website, and I send him the link to it because it is a complex, it's something that you just can't say to somebody, well, tell me about starlight and time and what you think. You just can't say it, you know, in a couple of sentences. It's a little complex. And also, I don't teach it dogmatically because when I witness to people, the evolution is the rock solid, the origin of life, that is just so scientifically impossible. If people believe that the Earth, because of starlight, is billions of years, so I don't teach that dogmatically. I know that half the pastors of Protestants believe that the Earth is old and the universe is old, and half believe that it's young. Okay, so in the congregation there's that issue. And it's complex, so I'm going to give you a general overview of it. And the question is, does it conflict with Genesis 1? Now, since on my website this is going to the general audience, I throw this up basically to listen to what I have to say, not ready to contradict it or refute it, nor to believe or take it for granted. I'm only asking you to weigh and consider this. Because for some people, it's going to go against the grain of everything that they have learned, and that came from Francis Bacon. And I think more on the issue of cosmology than all of the other topics is there's a lot of philosophy, a lot of religious belief that is masquerade as science in this issue. And there is a difference between what scientists believe in their worldview and what is a proven fact. And a proven fact is what's observable and testable. Now, I've talked about Anthony Flew, the world's most notorious atheist, and he wasn't just an atheist that said he was an atheist. He went on the offensive and wrote 35 books and debated C.S. Lewis. And in 2004, he said there was a God. And in 2008, he came out with this book. I recently finished it. I would highly recommend it. He was the son of a Methodist minister. And he went on to become the world's greatest atheist. He's now a believer, and he came to that before passing away in 2010. He said something great here. When you study the interaction of two physical bodies, for instance, two subatomic particles, you're engaged in science. But if you ask how or why those particles could exist, you're engaged in philosophy. And then here's the kicker. When scientists are engaged in philosophical analysis, neither their authority or expertise as scientists is of any relevance. So take off, when they engage in philosophical assumptions, take off the cloak of their white lab jackets and their authority and expertise, no relevance. They're no different than somebody off the street at that point. And most of our differences on this issue are philosophical, not scientific. Now, the secular version of origins, the Big Bang, is the best philosophical analysis without a supernatural creator. And it has the consensus of the majority of scientists. The National Academy of Science, 93% are either atheists or agnostic, so that's their worldview. It has the authority of teaching in schools and universities. Its underlying assumptions, though, are almost 99% philosophical, and therefore the consensus and expertise is not relevant, and the Big Bang explanation may not be the best scientific explanation based upon all of the laws of science. It is the best atheistic or explanation of origins without a creator. Now, this impact of authority of teaching and scientific consensus is why Aristotle was the one that said the universe has always existed. And that lasted, well, he was about 300 BC. It wasn't until 1970 that really started getting to be reversed. Even when Edwin Hubble was making an impact in the 1930s about it could be eternal, could have had a beginning, most every cosmologist preferred this because the beginning of time implied by a Big Bang imported religious concepts, which means, gee, if we came up with a Big Bang origin and it wasn't eternal, that's a little bit too much like Genesis 1. You might have heard Carl Sagan, the cosmos is and all that ever was. When he was making that statement, it sounded scientific because he came from a position of authority. It was philosophical. And it wasn't until the 1980s and 90s that the Big Bang theory, that the universe did in fact have a beginning. At one time it did not exist, and that is the consensus. Not only did they realize it had a beginning, it's still expanding. And guess what? It should be slowing down, but it's expanding at a faster rate, and that's a problem for them. Now, this expansion of the universe, the more I got into it, I was thinking, well, are these particles or galaxies coming apart or whatnot? It's not so much, it's the stretching of space between the galaxies that's expanding. And we're going to get into this because I thought space was void. It's a fabric, it's stretchable. And time is linked with space, and that's your space-time continuum. It's a great, when you're walking out with people and you're talking to the person next to you about the space-time continuum, that's very impressive. But here's what it looks like, is the expansion of space and the galaxies is being stretched out. So, according to Harvard, space has an unseen structure and can be stretched. Now, so therefore, the advocates of the Big Bang and the creationists like us, we agree. Since the beginning, stars and galaxies have been expanding away from Earth. Okay? We don't disagree on that issue. So there's consensus there. Now, the question is, how did the stars get there? So let's go to the Big Bang's explanation. They have to really explain what caused the universe to go from this to the universe that we see today. Now, I thought they believed it was nothing, but there's this, this makes sense. Nothing comes from nothing. From nothing, you can't produce something. You just get more nothing. So the assumption was in the beginning, it wasn't an empty void. It had fleeting electromagnetic waves and particles that pop into existence. Now, we don't know if these little particles have been there for eternity. That's kind of hard to imagine that they've always existed. And then if they did appear, what caused them to appear? No answer for that. But somehow those particles created a little ball, and that's what caused the Big Bang. So from that, and from little particles to that, is their explanation. Now, if you go to the National Geographic, they believe the entire vastness of the observable universe fit into this little pebble. That means the fabric of space, every molecule or atom you see out there on Earth, everything fit into that little teeny compressed, hot, dense mass. Now, the Big Bang leaves several major questions unanswered. One is the cause of it itself, and several answers have been proposed, but none have been proven. Again, this is not a proven fact. It's a philosophical explanation, if you will. And even testing has been a formidable challenge, and that's National Geographic. Now, in order to understand the Big Bang, you have to know a little bit about particles. And all matter that we see is made of atoms, and there's your neutron and proton and your electron. So those have to be produced. But there also has to be this particle zoo, because light, for example, travels by a photon, and you see a lot of these question marks. It's because they're hypothetical. They don't know for sure. They assume. Gravity, is that a particle? You know, dark matter, etc. This neutrino, that it comes from the sun, it's a particle so small that about 1 billion of them is going through your body a second. It goes through the earth. It doesn't stop, it goes through. You go, how can it go through my body and not have any damage? Well, most of your matter is made of empty space. And so it's like a golf ball going into a gigantic football stadium. You know, it goes right through. It's hard for us to think of us as mostly space. But if your nucleus was the size of a basketball and the electron was like a tennis ball, it would be 2 miles out there. Now, here's something pretty cool. You can't even get into particles and mass and all of that until you have the 4 fundamental forces of nature. Because without these forces, everything flies away. Exactly. The first force is the strong force, and it binds the nucleus of the atom together. That neutron and proton are bound together. If you split that, that's where you get your atomic energy in a bomb. That is the strongest force. A weak force is radioactive decay when one element changes into another. Without the sun's energy that we have, would not work. So that's cool. The other force is the gravitational force. And it not only binds the solar system together, it holds you, for example, into your seats. Okay? But what keeps you from going through the molecules in your chair? Well, it's the electromagnetic force that holds the molecules of your chair together. And your buttocks are held together, so, okay. But here's the cool thing. Good thing this is weaker than this, because this force could pull that atom apart. So, I mean, isn't that... Okay, so those 4 forces have to be there. Now here's the cool thing. These laws of nature of these forces, they're not physical. They are non-physical forces that act on the physical, okay? So I'm going to explain the Big Bang now. Here's the Big Bang. It's also the beginning of time. So before the Big Bang, there was no time. Time is linked to matter. So before that, it's a timeless state. When God created the universe, he was in a timeless state. He did not have time on his hand in the chronological sense that we're used to. It's a concept that I've had to have a couple of chiropractic adjustments to trying to understand this, okay? So, no time, and then within a thousandth of a second, the 4 forces of nature are created. That's pretty quick, that's necessary. And then in 3 minutes, protons and neutrons to make atoms are made. and then in a billion years, atoms and stars form, and galaxies form, and then that's today, 15 billion years later. So that's their religious belief, based upon a lot of philosophical assumptions. Let me show it to you here. What are we talking about? We are talking about, it assumes that there is a force that is not physical, that is outside of time, that predates the universe, that creates the universe from nothing. This sounds a lot like Genesis 1, but Genesis 1 was written about 3,500 years before they discovered this. That in the beginning there was a God who was not physical, who existed outside of time, who predated the existence of all matter, that created the universe from nothing. So you can see the similarities there. How did this mass come into existence? Well, the first law of thermodynamics says energy cannot be created or destroyed, only transformed. What made it go bang? I mean, how could that mass be there for billions of years and then all of a sudden expand?
Someone turned the light on.
Yeah. Now, are new stars being made? You probably have seen this photograph. It was all over the place 20 years ago, 21 years ago. NASA claimed this photo showed hundreds of stars. It was everywhere. 7 years later, what you didn't see is infrared detectors saw inside these nebulae, and there's too little dust and gas to support star formation. Not from creation science, but from Science News. The Big Bang must produce stars, and the theory is that dust clouds collapse to form the stars. This has never been observed. And one of the problems is it requires gas to compress down to a critical mass to form a star. But the problem is there's Boyle's law, and that is whenever gas is compressed, it expands outward, so it doesn't make that critical mass. Pardon me?
So, well, you have to have opposite reaction to the reaction you have in the first place.
Yes, yes. These are against the laws of physics. And besides, most stars are light years from each other, and also they're far from these gases and nebulae. Now, to the rescue is dark matter. It's hypothetical, it's invisible, it's undetectable, and it's all over the news. In fact, Time magazine has the missing 80% of the universe mass been found to search for dark matter. And what it does is the theoretical assumption, philosophical standpoint, provide maybe the gravitational energy needed to make stars. Now, I'm going to show you just the level of philosophical arrogance. This was Science Channel, how the universe was made. When a star dies, it provides the raw materials to build new stars, solar system, planets, and of course us. Every atom in your body came from the core of a star. Now these statements are made as though they're fact, and they're all philosophical, unproven claims. And the second law of thermodynamics, things don't go from disorder to order. They go the opposite direction. Less energy, entropy. Now, here's the big question when we get into the age of the universe. Just how big is it, and how do we know it's that big? Well, the first thing is, what is a light year? And it's a distance. It's not so much time, and it's to express how far light travels in a year. It travels about 6 trillion miles a year, or 186,000 miles per second. What I found interesting for the distant stars, they had already been calculated. And I'm going to show you how they did that in just a little bit. Photons always travel at the speed of light. That's kind of a cool thing about them. And radio waves do too. That electromagnetic spectrum pretty much all travels at the speed of light. Your voice on yourself. I was talking to my son in Germany, and it was like we were, next door, and it was going all over the place, and it travels. Electricity in a wire, signals inside your computer are examples. Now, for time for the light to reach Earth, the sun is 8 minutes. Our closest star takes 4.3 years of light traveling at the speed of light. Years or years away of light. Now here's the farthest star. The farthest star, they say, is 13 billion light years away, or it would take 13 billion years for its light to reach us. Therefore, the universe must be at least 14 or 15 billion years old.
But what happens, light travels in a circle.
That's 78,000 quadrillion miles, okay? For the farthest star to reach us, okay, I said that. All right. Now, before I show you how they do that, just out of curiosity, how many stars can we see with our naked eyes? And it's about 2,000 are visible, with 20/20 clear, and 5,000 from all the both hemispheres. Interesting, prior to the invention of the telescope, Ptolemy, a Greek astronomer, not with a telescope, had been invented, said only 1,000 stars were visible, and Brahe said there were only 965 stars. And so that's, I guess they didn't have 20/20 eyesight, but you know, they used these stars for navigation. They were critical. I mean, star charts were done. Interesting, the Bible in 620 BC said stars are countless. So what appeared to be a scientific error, you know, way back then, was pretty prophetic. How far away are these stars we can see with our naked eye? Well, 70% are less than 500 light years. It only takes 500 years for 70% of them, the light to reach us, and 94% are less than 1,000 light years. So, 94% are within that radius of 1,000 light years. The stars that we see are in our Milky Way. Here's the center. They assume it's that, the radius is that, and Earth is about here. So how is the distance of the farthest star determined to be 13 billion light years away? I'm going to speed a little bit through in this because I had heard something that Hugh Ross said, and I later, after doing the slides, discovered he had, in a public debate, said something that was very wrong. So I will, here's how it's done. They take the Earth, here's star A, and they measure it in January. There's the sun. And then in July, Earth's on the other side, and they kind of take that measurement there. And they know that we're average 93 million. And so here's out of a textbook. There's Earth and January, and there it is there. They actually, and there's the closest star to the right. And they actually just figure the radius from the sun, and they compute those angles, and they really calculate this distance right here, with that being a right angle, using trigonometry. Here's kind of what that star might look like. It's called the parallax. And here's the 90-degree angle there, and that's how the distance is done. Now, just to give you an idea, those triangles kind of look somewhat equilateral. But for the nearest star, if we put the scale of the base at 4.2 inches, the sides are going to be 20 miles. And that's for the closest star. That's a ratio of the bottom of 1 to 278,000. Something 13 billion years away would, light years away, would be 4 inches to 2.8 billion miles. So what kind of angles are we talking about here? Well, this is a 90-degree angle right here. And so this right here can't be 90 because it'll go out into infinity. It'll never touch. And these two have to equal 90 degrees. The closest star is 89.9998 degrees. And so this angle here is going to be 0.0002. A degree is 1/30 of, okay, arc minute. I'm going to just, okay, the farthest, I'm going to just tell you. Remember when Hans said the star, his Millennium Falcon, can do less than 12 parsecs? Well, a parsec is 3.3 light years. Okay. Here's what the facts are. Space-based telescopes can get accuracy to 1,000 parsecs, so the space-based can only go as far as 3,300 light years, 3,300 light years away. That's the best that we can do with space-based telescopes. And then Europe launched this space observatory, and the maximum distance, according to Ohio State, that we can get is 32,000 light years away. So the most that we can know using a millionth of a degree, which is pretty small, is 32,000. All of the other greater distances are assumptions made about presumed size, intensity of stars, redshift as they move away, nothing to do with any distance. So the bottom, what we're actually able to know for sure by our measurement is a small fraction of the 13 billion light years. So the 13.5 billion light years distance and therefore age is an assumption. Its true distance and age is unknown, and it's big. I'm not gonna say it's teeny. It's been expanding. It's big. It's expanding faster. Why are they so adamant that that distance has to be 13 billion? It's necessary to provide enough time for the evolutionary model to work. Because with the Big Bang at least 15 billion years ago, then we have stars forming 5 billion years later, then we have our sun and the Earth forming 5 billion, and then the ocean. We have to push the Big Bang out as far as we can for these other natural processes to occur. If our universe has been expanding, how much smaller was it in the beginning, whether you're the creation model or the other? And has the stars, the distance of all of this is based upon the speed of light always being constant, okay? Now, they do not allow creationists to say, well, we can solve that problem with a faster speed of light. We don't need to, but they don't allow us to do that. But they do. This is Discover magazine. Look at this, actual size of the universe at the beginning. The universe burst into something from absolutely nothing, zero, nada. Anyway, that's their story. But he goes on to say, for light to get to the outer limits, it traveled faster than the speed of light. There's the cosmic background radiation. It's the oldest light in the universe, and the temperature is the same pretty much everywhere. It's called the horizon problem. And there's not enough time at 13 or 15 billion years for the warmer radiation to travel to the cooler areas. The solution, variable speed of light. And this guy's pretty famous, reinventing gravity. A much faster speed of light in the infant universe solved the horizon problem and explained the overall smoothness of the cosmic background radiation. Now, I've said all of this. It's been a little dry and a little boring, but it's a necessary foundation to get the last two, okay? So this is where the fun stuff. Is the speed of light always constant? Well, I've shown that, at least in their explanations, they said it is not to solve their problems. What about time? Has time always been constant? Well, prior to the 1990s, you're right, belief was time was constant, no matter where you were in the universe. Today, we know that the passage of time is dependent upon an object's velocity and the strength of gravitational fields. Now, Einstein, his theory is the method of two people agreeing on what they see if one of them is moving. Here's a simple illustration. Let's assume I'm in a car traveling in the back seat, and I've got a tennis ball and I throw it up and down. To me, it looks like the ball goes up and it comes down in my hand because we're both traveling at 60 miles an hour. But if there was an observer on the side of the street and he could see through the car, he would see that that ball traveled in that arc, because he's relatively in a different position. That's kind of a general understanding of it. And what his theory is time is different if one moves fast enough through space. Here's kind of an example. This is like a chronological flow of time into the future. And if this is you, let's say on Earth, and this is a spaceship, this slice represents present now. But if that spaceship gets up enough velocity, he's going to cut through time at a different angle due to speed. So that's kind of visually, that was from PBS Nova, kind of an example of what that might look like, because to me, I needed another chiropractic adjustment after that. He also, so time is different if you move through space. The other thing that he predicted was gravitational time dilation. That time is slower in gravitational wells caused by the mass of an object. He predicted that. It was confirmed in 1959. And it basically says, and this is the fabric of space, the sun, because of its mass, creates a gravity well, and this is actually the fabric of space being stretched. This is, let's say this is Earth, and if we were on Earth, and if we could see a clock on a distant star, we would see that that clock is spinning very fast. If we were on the star and could see that the Earth, and we could see the clock on the Earth, to us, time would be normal, but we would look back and we would see that clock going very slow. So that's it's like, for some reason, I don't quite get it, because if it seems normal to you, I don't quite get that yet. But this PBS, The Illusion of Time, is a great YouTube. So prior to the 1990s, the belief was space was void and empty. Today, it's, according to Harvard, a stretchable, flexible thing. Property still unknown. As space stretches, it stretches time with it. And here's an example of a science experiment in a university. Stretchable fabric. They put an object and it creates that gravitational well there. You see these gravity wells, and you can throw marbles. They go slower here and they go faster in the inner. Now on these gravity wells, because of friction, they're going to eventually end inside the middle. They're just going to all fall in. But in space, there's not that friction. So if you get these objects in motion, they'll continue to go around. And this is kind of what it does. There's the Earth, and the Earth makes a gravity well in the fabric of space. And so time is slower at the closest to the gravity well, and it's faster on the outer skirts. And we see that in the space station. The atomic clock on Earth measure, and then you have atomic clock on the space station. One day, it's faster. And the space station, which is 10,000 miles further, the GPS satellite, is even faster.
Sorry.
Now, I didn't know this. I thought astronauts floated in space. They don't. They're falling. Any orbit is a constant path of a free fall. Everything's falling. The spaceship is falling. It's kind of like you jump off a building and you've got a desk next to you. You're all falling. So if you stop and think about it, the space station is only 220 miles above Earth. That's only 10% less gravity out there. It's 4,000 miles to our core. So it's only 10% less gravity where the space station is as compared to right here in Riverside. What's keeping it from eventually crashing is its forward speed. Now gravity is holding it in, but you've also got that gravity well, so it's going around and around.
Conservation of
So the
Indian
Earth makes a
Ocean.
gravitational well, and the space station is traveling at 17,000 miles per hour, and the moon is traveling at 2,000 miles an hour because it's much further. We go into our solar system, you've got Mercury, there's just a massive gravity well, and keep in mind in this, these things aren't stationary. We're talking about waves because the sun is moving 600,000 miles per hour. Everything's in motion, stars are in motion, so these gravity wells are not stationary, they're moving. There's Mercury at 106,000 miles, Earth is then slowing down, and you got Jupiter at 29,000, and then Pluto is at 10,000. And if Earth slowed down, it would eventually fall into the sun. Now here's something pretty cool. National Geographic. Everything in our solar system moves in a stable, orderly fashion. This is unusual. Jupiter's large gravitation helps keep Earth's orbit very close to circular. It goes at National Geographic. Elsewhere in the universe, orbits are unstable and chaotic. Giant planets hurtling into their stars, planets colliding with other planets, galaxies colliding with other galaxies. This is the norm. So outside of our solar system, it's dangerous out there. It's not as orderly as this God-created Earth. Now, here's the weird thing. Gravity and speed, time and space can be bent, shrunk, or expanded. And here's kind of an important difference between the Big Bang and the creation. Is our galaxy, or Earth, near the center of the universe? The Big Bang says no, and the Big Bang, can't be proven. No center. Big Bang, not an explosion. In the beginning, it was filled with energy. There's no center to this expansion, and the Earth's position is not significant because the Earth is only one of many meaningless specks, according to Harvard. The creation view, which scientifically we don't know all about the universe. Earth occupies the central position during creation. Distant galaxies, from a scientific standpoint, are visible from Earth in all directions. Galaxies are moving away from us in unevenly spaced groups, and the cosmic background radiation is uniform in all directions. So there is scientific pointers that we are at the center. With Earth near the center, the fabric of space began stretching outward. Galaxies' distance from Earth increases, and days on Earth would be millions of years in the furthest galaxy. So when Genesis was written, it was recording the clocks on Earth, not the clocks in space. And Dr. Russell Humphreys, he believes that the universe may have been 50 times smaller during creation. The gravitational time dilation would have occurred, and the Genesis reference to time is based upon Earth clocks. And his belief is what would take time and space would be millions of years, would be days on Earth. Now, and kind of wrapping this up, what is the probability that natural process alone could create a universe, planets, and life? I know you've heard of the, the anthropic principle. We live in a world of astronomical unlikelihood. The anthropic principle. The universe appears to be carefully designed for the well-being of mankind, according to Scientific American. And in fact, the person that invented this term said, it's pretty strange inequity of a universe that spends 15 billion years preparing itself for a creature, mankind, to evolve, whose potential to survive is no more than a few million years. Freeman Dyson, who is one of the world's greatest theoretical physicists, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense knew we were coming. I'm going to just give you a few. There's hundreds and hundreds. If the gravitational force were altered by that percent, neither Earth nor Sun would exist, and you and I would not be here reading this. He's an atheist, and that's his position. Stephen Hawking's, if the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in 100,000 million, the universe would have recollapsed before it ever reached its present size. He does go on to say, however, it would automatically become very critical due to the density of the universe. What he's saying is, well, it had to happen that way because we wouldn't be here if it didn't happen that way. That's a little circular reasoning. The sun's magnetic field protects our entire solar system from charged particles in deep space. That even goes, there's like Pluto goes beyond, because there's charged particles in deep space that could damage in our solar system. And even the Earth's magnetic field protects us from our own sun's solar wind, and if we didn't have this strong magnetic field, it would strip away our atmosphere and we would die. Mars and Venus, for example, have no significant magnetic field. So they have a very small atmosphere, but not enough to sustain life as we know it. Our atmosphere, the surface gravity prevents atmosphere from rapidly losing water to space. The ozone layer filters out harmful radiation. The atmospheric pressure enables our lungs to function and water to evaporate at an optimum rate to support life. Now, let me just explain one thing about Genesis 1 that I think is sometimes confusing. The Bible speaks of 3 heavens. The first heaven is our immediate atmosphere, okay, where the birds are. The second is outer space as far as it's been stretched. And the third heaven is where God dwells, okay? So, just to explain this, on day 2, let there be an expanse in the midst of the waters, and let it separate waters from the waters. And this is the ESV version. And God made the expanse and separated the waters that were under the expanse, and that would be our atmosphere. Goes on to, and verse 20 goes on to say, the birds fly in the expanse of heaven. That's between our atmosphere and at this time on day 2 it was just water. And that were under the expanse, from the waters above the expanse, and I would say that's called interstellar space. God called the expanse heaven. So this is what, now this is not mine, but it's many scientific model, if you will. Scientific models can be changed, but they can't contradict Scripture. So, you know, and this would be the second heaven. Day 3, and God said, let the waters under the heavens be gathered together into one place, and let dry land appear. So then it was probably a supercontinent, not the form it's in now. Let earth sprout vegetation. And then on day 4, the sun, moon, and stars were placed in the expanse. And the expanse is the interstellar space, and then the fabric was stretched. Now, Genesis 1:6 kind of implies during creation there was a layer of water created as the boundary far away in space. That's what some would conclude. The fact is, water is the most abundant compound in the universe. Now, only on Earth is there liquid water that we know of all the planets and all of the moons. So it would probably exist as vapor or ice. The reason why it's the most abundant is the most common elements in the universe are hydrogen, helium, and oxygen, and H2O. This was 5 years ago. Astronomers find the largest, most distant reservoir of water. The water surrounding the quasar over 12 million light years. The water is equivalent to 140 trillion times all the water in the world's ocean. Somewhere out there in outer space. Water's been prevalent in the universe for nearly its entire existence. This is from NASA. Now here's the Hebrew word for expanse is rakia?
Rakia.
Rakia, thank you. And it means an expanse or something spread out, stretched, made thinner. 17 verses from 7 books in the Old Testament refer to the stretching like fabric of the heavens. Job 9:8, who alone stretches out the heavens? Isaiah 40:22, God who stretches out the heavens like a curtain. So on this, given the fact that the Bible was written, or Genesis was written in 1450 BC, there were a lot of pagan beliefs. And the Bible remained true not to those pagan beliefs. It said it had a beginning when the pagan belief was, it was eternal. It said the sun and moon were objects, not gods. The pagan belief, all the way through the Greeks and the Romans, believed that the sun and the moon were deities. It said that the space and the heavens had been stretched as they are continuing to be expanded. It said the number of stars cannot be counted, and it implied that there was water in space. So, home stretch, summarized, what's the big difference, bottom line? Big Bang, size of universe was smaller billions of years ago. A younger Earth, size of universe was smaller over 6,000 years ago, measured in Earth time. Stars and galaxies formed after the expansion. Stars and galaxies formed before the expansion. They were created, and then the heavens were stretched. There's no center under the Big Bang universe to the universe. The Bible is the Milky Way. Earth is the center of the universe. Big Bang, impossible for universe to be less than 13 billion years old due to distant starlight. The Bible, with the Earth at the center of the universe, time moved faster in space than on Earth. I should probably say the creation science model, because the Bible doesn't specifically say that, it's implied. Earth, under the Big Bang, is one of many meaningless specks. The odds are astronomical that another planet has all the right conditions for life. Big Bang, stars formed first, and its particles made plants. Life appeared, and then people. Bible, Earth formed first, then stars, and then later on people were formed separately. The origin of life under the Big Bang, of life and mankind, was a random accident from Big Bang debris, leftover stardust. Bible creation model, life and mankind were supernaturally created. The complexity of life boldly testifies to that observation. And then here are 3 secular assumptions they make for us: that the speed of light has to be constant. They often use a faster rate, but we don't really need it to be faster, to be honest. Time on Earth is the same as in deep space. We know that velocity and gravity affect time. If Earth was the center, light that takes billions of years to reach Earth, as measured by clocks in deep space, could reach Earth in only thousands of years as measured, or days, by clocks on Earth. And then they say that the philosophical questions of origins has to be limited to only natural process. The laws of nature and physics are how the universe is maintained and sustained, not how God created it. Creation was a supernatural event. There simply are no godlike natural process capable of producing that type of complexity. And Creation.com lists 192 scientists, all with PhDs who are alive, who believe in a young universe. Degrees in astrophysics, aeronautics, nuclear physics. One of them, for example, became a believer at age 48. His PhD focused on distant galaxies 200 million light years away, and because of all these issues, believes the universe is young. I just touched on Starlight because that's the big issues. There are other things that people can go into, and this is just a handful. One of them, this was just last year, when the New Horizons swept by Pluto, the age of Pluto, which was thought to be the same as Earth, was changed from 4.5 billion to 100 million years due to lack of craters. And there's a lot of crowded objects out there where Pluto is. In fact, mountains are still in the process of building. There's like three minutes. If God created the universe, I get this a lot. Then who created God? Stephen Hawking said it, Bertrand Russell said it, Richard Dawkins has all said it in their books. All right, if God created, then who created God? There's a principle of causality. Everything that has a beginning, everything that comes into existence had to have a cause. Now the secular believe matter came into existence, they don't have a cause. The answer is that God is not a created being. He is infinite. And this concept is outside of our comprehension. And it's kind of like that in terms of infinite. Time began when the universe began, and time is linked to matter. So God existed outside the time that we know it. And before creation, there was a timeless state, and God didn't have time on his hand. Now here's the cool thing. A person who exists before time can be anywhere in time, including the future. So if you're not in time, but if you existed before time began, then you can be anywhere. And we see a glimpse of that when John in chapter 4 is taken up in the Spirit to see future segments of time that will occur in the future. And that was revealed to him. He had no idea. And then this is this is the last slide. It's just to say, even if you don't agree, if you don't understand, in the bottom line, none of this is important if you understand that there is a life after death, that you need to be saved from your sins because you're not good enough, and believe that Jesus' sacrifice on the cross means you will not perish but have eternal life. If you understand and believe these things, then the rest of that is just something to think about and maybe to answer questions with, because one of my faults is I try and understand everything, and I simply, it's like a dog learning calculus, I simply can't. So I'll throw it open to questions at that.
Chiropractor.
Yeah, chiropractor. Yes.
This isn't a question as much as a comment. You quoted a verse there out of Isaiah that talks about how God spread the heavens out like a curtain.
Yes.
The word for curtain there in the Hebrew, it's the only time that word occurs, and it literally means a lattice or lattice work. It's kind of interesting to note that pictures having to do with the gravity wells are like a lattice.
Yes.
It's like a fabric that's with squares on it that you can see how it's bent.
Yeah, I found a quote that said that the universe is not random, but there's equal space, and they called it a lattice work as well. And this was from the secular standpoint. Yeah, there's like 17 of them that refers to space just being stretched. Yeah, good point.
I found it interesting that little model that they showed in the hand of the little pebble, they said there was no place that it started or where.
Right.
They undesigned their own theory by saying that it started there. It had to start somewhere.
Yes.
And when they said it didn't have any place of origin, it's the same circular reason: something from nothing, nothing from something.
It does seem kind of peculiar if they're saying it was something A big, but it wasn't anywhere.
Yes. And now, this is their best current model. There are a lot of scientists that are having difficulty with it, but they don't reject it until they have something better. Yes. Charlene, did you have a question?
Well, there was a scientific principle called the first cause. Or God is the first cause.
God is the first cause, yes. Yes.
Klaus, were you saying then that Isaiah was like Descartes, only smarter?
Probably he was.
Now, you probably have heard they've also invented multiverses because it's like, well, there's got to be multi-universes all over there, and even the secular world kind of, it's just, they're just trying to come up with a solution.
When you were saying the 192 scientists have believed that it's not an old universe,
Yes.
but do they have a number of what young is?
They believe, I think, that the Earth, as measured in Earth time, is like under 10,000 years.
Oh, so closer to what
Yeah.
was true.
And that the time, as it gets further away from the gravitational well of the initial creation, time is faster out there. And so we had a time dilation, and we had the speed, so we have all those factors. Russell Humphreys believed that at creation it was 50 times smaller, so.
So they're not in the billions and millions
No,
anymore, they're
no,
in the
No,
thousands.
because they understand, they know what the calculations are based on. They understand that mathematically we can only go 13,000 miles. It's bigger than that, but whether it's, 13 billion, it could be 13 billion, but that doesn't mean that the creation event was 13 billion years ago because of the time factor.
Right.
I mean, time being stretched, time being hooked to matter, I mean, that's, yeah.
Yeah.
That was so you could go back in time as well as forward, and you can't.
Yeah, I learned from this that I never say can't.
No,
I
there's
just
only one
don't know.
direction that time goes.
Yeah. Science fiction can go back in
From
time.
the
right?
beginning to the end.
Okay, well, thank you. Any last questions? Okay, thank you.
Ladies and gentlemen, there will be further opportunity to talk.